Hi, you're welcome again to my design class. I'm Joshua the designer, and I'll be taking you structural steel design course. At the end of this course, it is expected that you are able to design by yourself a steel structure and the respective members. Anyways, so be sure to pay attention to every bit of our communication, and then if anything isn't clear, please do well to ask for clarity, and I'll be willing to do that for you. All right, so to begin, we'll have an introduction into the course. I believe that by now you should have had a prior knowledge of concrete design. So, similar to concrete, steel is also a construction material used to build various types of structures. And I know by now you would have interacted or you'd have even seen structures that are made constructed with steel. It can be utilized on its own, that is completely a steel structure, or combined with concrete in what's known as a composite structure. Example of steel structures is exactly what you're seeing displayed as in a picture on the right of my page. Here, a steel structure. Okay, so a structural steel is manufactured by two means. Is either through hot rolling or cold rolling. So what do we mean by rolling, or let's say cold rolling? Cold rolling, thin steel plates which can be formed or forged into a wide range of sections by cold rolling. you know Cold rolled sections, they are used for specific members like Z-pole lines, Z-pole lines, or sheeting railings. And you see elements like the Z, the C sections, and the sigma sections. I have a picture of them in this. Now, looking at this right hand side, you see the Z section there. You see that now. You see the C, the C section there also. All right, and we also have the sigma section. All right, but in any case, rolling, by saying rolling, it refers to the way with which the steel material is produced. So we have the cold rolling and the hot rolling. The rolling is just the method, the way the steel is produced. So when we say hot rolling, it has to do with extreme heat treatment. So it occurs at a very high temperature. So we have large rectangular metals which we refer to as billets. So when the billets are heated, then they are sent for processing. So, and after that, or at the stage, they are flattened into shapes, into large rolls. So you can see examples of these roll sections, and basically in this course we'll be designing a whole lot of road sections, because most of your structural steel members are manufactured, they are hot road section. They are hot roads. They are hot road they are mainly produced at extreme heat temperature or heat treatment. So example of steel members that are produced by such means is the H sections. You see the road beams and column sections, the channels, the road channels, the rectangular hollow sections too, circular hollow sections also, the single angles, the double angles, the T's, and compound elements. So these are elements that are produced by the means of hot rolling. All right, so you just have to note that. Also, there is structural steel grade. Structural steels are produced in three different grades: S275, S355, and S460. If you could recall for reinforced concrete designs, we have the high yield reinforcement and we have the mild steel reinforcement, of which the high yield reinforcement you have several characteristic strengths like 460 newton per meter square, you have 410 newton per meter square, and some other characteristic strengths. Also for mild steel you have 250 and whatever. So in this case also you have three different grades, of which whichever applies to your design you can apply. So for example, grade S355 steel has a minimum tensile strength of 355 newton per millimeter square. So how do we get about that? So you discover that under S355, referring to the table 9 on the right, as you can see, you will discover that we have several thickness on the second column, which is 1640, 6380, 100 and 150 mm. Okay, so from there you discover that your thickness would determine what your design strength would be. So the minimum tensile strength, sorry about that, the minimum tensile strength is 355, which is to say that if you are using a steel member that has a flange thickness of 16 mm, it means that the design strength automatically is 355. That's how it says. So if you're using an element which the flange thickness is 150 mm, for example, it means that the design strength would be 295. All right, so table 9 of BS 5950 part 1, all right, which is a supplementary document to this course that you have already. Okay, so is exactly the one reproduced to the right, so it's found in the code. It's actually extracted from the code BS5950. Shows the design strength py related to the thickness of the material. The relevant thickness for a row section, like I said, is the flange thickness, the relevant thickness that we deal with. Of course, we know that we have the web thickness and we have the flange thickness, but in determining the design strength of any section, then we use the flange thickness. The current use of various grade of steel sections is as follows. There are various uses of the steel sections. So grade S275 is the lowest in cost and commonly used. All right, grade S355 is cost greater than S275, but also is economical where deflections are not really critical. Grade S460 has a higher design strength and is rarely used. All right, so let me know if you have a question at that point. So like I said earlier, the relevant thickness for row section is the flange thickness. You must have gotten that now. It should be noted that steel sections are most often used for structures where loads are large, so where you have large loads and when you have spans that are large, you use your steel sections there. And it is normally not used for domestic architecture. That's true. For buildings that are small, where you find steel structures are usually large span buildings and buildings that has very high load, you know, to be sustained or supported. All right, so there are advantages and disadvantages of steel structures, which I feel is important that we know before we go ahead. All right, one of which under advantage or advantages is that it has high strength. Also, it is resistant to vibration due to high stiffness. It it constitutes a lighter construction and it has a cheaper foundation. No formwork is required, of course, you know. Achievement of fast constructions, yes, because you don't have to wait for the concrete to achieve its desired strength, like the 28 days strength, you know. Height of structures can be easily extended. At certain points you may decide to create a connection to extend the height of your structures, which may be very impossible using concrete members. So achievement of better quality control also is an advantage of steel structures. And under disadvantages we have that it has poor fire resistance and it requires high maintenance cost. Also, poor flexibility, and it requires skill erection team, and is also prone to corrosion. Yes, I have some other properties of steel that I would like that you master, because they'll be useful when we start our calculations properly. So for elastic properties of steel, the following values should be used. The modulus of elasticity, which is the capital E, is 205,000 Newton per millimeter square. And we have the shear modulus G to be E in bracket E over 2 in bracket 1 plus V, which is the Poisson ratios. And the Poisson's ratio is 0.30. We also have the coefficient of linear thermal expansion, which is 12 times 10 raised to the minus 6 per degree Celsius. So this is fundamental to our next course, our next class rather. So because in the next class, I'm taking you introduction into connection design of connections, steel connections. So, or even before design of steel connections, I may have to teach you member selections, how to rightfully pick members sufficient for the load that is subjected to. Maybe we'll start from there, or I'll teach you on how to select member selections, and then we'll pick up our designs from there. If you have questions along any point, please do well to let me know, and I'll be willing to answer to them all. Thank you for listening. See you in the next class. Bye.